Hey folks, welcome to the webinar. Welcome back to Sustainable Design Masterclass. We're going to get started in just a minute or two here. We're just going to do our introductions and say hello to everybody. But yeah, this is going to be a fantastic session. We've got the whole Rain for Climate team back on, and this is such a pleasure and a privilege to have these guys back on because they put so much dedication and effort into helping put these on, and what they do is absolutely incredible. It's mind-blowing, and so I'm always excited to share this with you. And Neil and I are always stoked. That's why we doing a 6-part series on water restoration, because this work is so important. It's so simple, it's so effective, and it's so powerful. So before we get started, let me know if everyone can see and hear the screen all right. Just type in that chat box below. Let me know, if you can see, hear everything all right, where you're coming from. It's great. Elizabeth coming in, good. You see everything? Lee's saying sounds good. Awesome. George says, hey guys, everything looks and sounds good. Yes, can see and hear. Awesome.
All right.
Plen coming in from the Netherlands. Great. How about we get started? Neil, you want to do a little SDMC intro?
You bet. Welcome to Sustainable Design Masterclass, everybody. This is a show that Raleigh and I put on average every other week. We focus on environment, agriculture, entrepreneurship, and really trying to answer the questions of what do we need to do to create sustainable human civilization, and how do we do it? And we've got previous webinars we've done on these topics. We've got some really great ones planned coming up. The next one will be 2 weeks from today with the senior policy and science advisor to the World Agroforestry group. And we're excited to have you on here, excited to be doing this with the Rain for Climate folks who we love the work you guys do and respect it deeply. And Raleigh, you take it away from here.
Okay, great. So yeah, as a quick reminder too, make sure to get the most out of this, make sure you close your Facebook and all these silly background things. You don't want to be distracted. These guys have put weeks and weeks into preparing this, so give them your respect. Give them your respect. And also, you don't want to be distracted, and it'll slow your internet down, so make sure you close those. So again, I'm really excited to bring back on the Rain for Climate team because Mikhail Kravchuk and Jan Pokorny and the authors of the New Water Paradigm, they started this plan called Rain for Climate, and it's mind-blowing because it is one of the most direct, effective pathways to doing something that almost seems too good to be true. But when you read into it, you're like, oh my gosh, this is an incredible solution. It's water restoration. It's effective climate stabilization by repairing the small water cycle. And so I encourage everyone who's new to this concept, please visit Rain for Climate, read up on this, because I was introduced to New Water Paradigm by Dr. Russ Spear here, and it really changed my world because we've been living in our relationship to water it's so different. We think only CO2 is the one factor in climate, when really water is arguably as important, if not more important, for controlling our climate, for restoring our ecosystem, and it can be implemented effectively, cheaply, and rapidly, as you'll see in examples that they're going to show in Rain for Climate. And this applies from anywhere, from right now what's going on in Cape Town, for what we experienced in California, to drought in Spain, in Greece. Everywhere can use these solutions that Rain for Climate is talking about to effectively repair the water cycle, to effectively repair the weather and make it rain. So this is absolutely incredible. You're going to be blown away, and I'm excited to bring on and have this started by Vlado. So welcome back, Vlado. Oh, Vlado is the head of one of the lead organizers at Rain for Climate, so it's good to have you on.
All right, thanks a lot, Raleigh. Well, thank you for having us. So first of all, a warm welcome to everybody who is online with us or whoever is watching the recording. So thank you very much for spending the time with us. And well, we're just very excited to actually have a look at what we can do in order to restore the climate and how we can work collaboratively and globally to make things happen. Now, in terms of the logistics of the call, so basically there would be myself leading the webinar part, the presentational part. So this would be somewhere around 50-60 minutes. And then there would be Michael and Jan and myself also happily taking the questions, should you have any. In terms of the program that is on the plate today, so we are actually thinking about doing a quick polish in terms of the previous webinar, because it's kind of critical information that we have disclosed there. And it's really essential to be understood so that we can follow up and carry on afterwards. Now, we are going to have a closer look on the actual analysis of the real-life scenarios in a couple of places worldwide. We are going to touch base on the relationship between the sea level rise and how the desertification of the continent is related to it, and also the relationship between the carbon and water and what it has to do with the climate. On top of that, we are going to have a closer look on a couple of projects that we have done or our partners have done worldwide, and how the lessons learned from those have shaped the rainfall climate to what it is nowadays. And last but not least, we are going to spend some time on the rainfall climate itself to make sure that we do explain how it was designed and the principles it was built on, because it's essential that this needs to be understood if this is to become a global movement. So first of all, a short summary on the rainfall climate and what we have gone through in the first of the webinar. So our goal is to become the umbrella program for the communication and for campaigning. It's absolutely essential that people, regardless of the location, they do recognize the rainfall climate as, oh yeah, this is the thing that can help to stabilize the climate. And no matter whether you are in North America or Australia, it should be identical. This helps to keep the momentum, and this helps to bring the attention of the ordinary people. The aspiration that we have is actually to carry on with the center of excellence that we've got, and we want to specifically carry on the collaborative and also on the quality of the work that is to be performed. This is absolutely essential because the rainwater retention measures, when they are implemented, they also need to be done well and effectively to make sure that they are not going to lose the effectiveness over the time, or they are going to not function at all. Because if not done properly, again, this hurts the concept, and therefore it is absolutely essential to make sure that we know what we are doing. And the rainforclimate.com should be a data repository for anybody who would like to get familiar with the concept. So this should be sort of golden source of information, where the original information, which are definitely coming from the right source, right from the authors, is coming from. Again, this is for the sake of keeping the quality. And our goal is to actually initiate the grassroots movement. So we start from the individuals, we start all the way with the crowd, with all of us. And our goal is to build our way up towards the politics. And the road we are going to take is going to lead through the mainstream. Good, so that would be it in terms of the short summary. Now let's have a look on the previously disclosed information in regards to the solar energy and how it distributes over the earth. So once again, what we are looking at on the left-hand side, there would be the territory which is lacking the water, and the territory which is saturated with water is the green one on the right-hand side. If we take out all the components that are identical, so like the reflectance or the heat flux, what remains is a big difference in terms of the sensible heat and the transpiration and evapotranspiration. And the healthy environment saturated with water spends around 80% of the high dosage of the solar radiation on the evapotranspiration. So this is where the high amount of energy is consumed on the physical principle of changing the state from the liquidus water to gaseous. And only about 5 to 10% remains for the sensible heat. It's just the opposite where you have a dry land, where only a little bit of the water that is left on the territory is used for the transpiration and the evapotranspiration, and the rest turns into heat. Now what happens afterwards is that, again, on the healthy territory, once the water will get evaporated into vapor, it's being taken up from the troposphere to the higher level of the atmosphere, where it reaches lower temperatures. And once it reaches the right temperature, a dew point is reached, the water condensates back, and where it releases the latent heat it had previously consumed, and the heat, the energy is radiated to the outer cosmos. This is the very thermoregulation mechanism the Earth has been working with for ages, and we managed to break it down just precisely through the means of lack of water on the territory, which is the situation on the left-hand side. So on the left-hand side, we are looking at the territory which is overheating, and what happens is that the heat, the sensible heat, remains within the lower levels of the atmosphere. And this is precisely what is causing the kind of awkward weather and the weather disturbances that many of you have been already familiar with. And the effect it brings, regardless of whether it's a city or agricultural land, is that within this dry territory, there's a higher temperature. There's a higher temperature, which is somewhere above the territory, according to, hold on just a second, let me get rid of this, okay. There's a higher temperature compared to the territories around. And what happens is that the air is actually pushing, the heat is pushing the cooler air out from the overheated areas to the cooler region. And the effect to that is the turbulent weather. The effect to that is the precipitation which is accumulated in the cooler region and the lack of precipitation in the overheated areas. Good, so just let me erase the drawings, and we are moving on to the next one. So now let's have a look on the first of the island, which is literally an island, a heat island of Cyprus. So what we can see on this picture, you can actually literally see how overheated the island is and how the clouds are flowing around. I mean, this really is mind-blowing. This is a satellite picture when you are looking almost in real time, like how the function of the heat island impacts the local weather on Cyprus. Now, what happens in Cyprus is that once you get the weather a little bit warmer, so the summer starts somewhere around April, the temperature will start rising, and accordingly to that, the precipitation will start diminishing. So what you can see on this graph, that through the summer, so from April all the way down to around October, November, late November, the precipitation is actually declined as the temperature from the overheated territory is rising. What is very important to notice is that in Cyprus, over the past 30 years, there was a decline in precipitation of around 15%. So they have lost around 52 inches of rain over the past 30 years. Now moving on to the next one, we are going to have a look on Greece, and welcome to the Acropolis, the center of Athens. And the cities, in very nature, they basically, as they have been evolving, the channelization started to evolve, and the channeling of water was taking place ever since the settlement started to occur. And again, it has taken its toll on the temperature. So again, very similar scenario, starting from April all the way down to approximately October. You can see the temperatures rising and the precipitation declining according to these. And infamously famous Cape Town with the day zero approaching. So this is actually a critical point, if you would, or location where we can observe what happens with once the ecological systems are distorted. So actually, what we see is that the ecological systems are distorted, and the price that it takes is that once the temperatures will start declining, since we are talking about the South Hemisphere, so around April, again, you can see that the rainfall actually rises as the temperature decline. But what happens long term is that they have lost over 100 millimeters of the rainfall in the past approximately 80, 90 years. And the price for that is the externalization of the precipitation. So what happens is that where the precipitation should occur over here in this time frame around May down to August, so it's quite likely. The result of the externalization is that it either is not going to show up at all, or if it will show up, it's going to flush out the city because it would be enormous. So that is the price that we have for distorting the ecosystems. Now, apparently, the solution within the big dams is not sustainable long term, and it is time to start on building up the ecosystems and restoring the small water cycle. By the way, for the Cape Town ourselves, we have approached the municipality and we have proposed them cooperation. So at this point, we are still waiting for the feedback to see on how we can launch an international collaboration to get things done. Now, let's compare the heat island impact or effect in the western coast of Africa. So it was Michael who actually has chosen the location because it illustrates really nicely what we want to disclose as a message. So we are looking at 3 different cities. They are pretty much in very similar geographical area. In terms of the solar daily intake, they are more or less identical. And what the difference is the amount of ecosystems that do remain in terms of the foliage. So now let's have a look on the first one. So Monrovia. So Monrovia actually is, as you can see, it is located down south in the tropics. And in terms of the precipitation, you can see that the precipitation is distributed more or less evenly through the year. Now, I would like to bring your attention particularly to the numbers on the y-axis. So what we have, let's take 200 millimeters or 7.87 inches. Just kind of keep that in mind. So this is probably the highest the precipitation gets over the summertime. Now moving on to the next one. We are moving up north to Dakar. Now what happens in Dakar, so we are moving on the semi-arid area, the amount of precipitation overall remains more or less the same. I mean, it rains around 18% less than in Monrovia. But what happens to precipitation is that it does get extreme. So as I called up your attention previously to the graph, so this is those 200 millimeters on the y-axis. And what we can see in terms of the distribution, that half of the precipitation actually falls within the rain season. This means that the small water cycle is actually partially empty, as opposed to Monrovia, where it was functioning well, which we can see on the distribution of the rain. So, and coming to the extremes, again, we are looking at almost double of the amount of precipitation in the rain season. Now moving on to the next one, we are going to move up north. So up north in Nouadhibou, so those 200 millimeters that I called your attention to, they would be somewhere around here. So you can see that we are not even making it that far. There is literally no rain in the desert area. This is due to the fact that a large amount of sensible heat is being produced, and it just simply will not allow the cold and humid air from the Pacific to enter the inland. So this is the impact of the heat island as demonstrated on different locations. Now moving on to the next slide. So what happens in the desert areas? I mean, honestly, life is going to find its way. So it is not like it is the end of the world. Nevertheless, apparently within the desert areas, the ecosystems are not thriving. So the more water we lose, the less life is going to be supported within the area. Now moving on to the next topic, which would be the sea level rise. So one might ask, so what does the small water cycle has to do with the sea level? Actually, what happens is here on the left-hand side, you can see the small water cycle being emptied in the different times in the history. And so Michael's calculations actually prove that we are raising the sea level by 2.1 millimeter or 0.08 inch annually ourselves. This is the 760 cubic kilometers or around 170 cubic miles that we channel from the continents down to the sea. The impact it will have, we all know it. Part of the cities, the coastal cities, are in danger of the floods and at verge of complete destruction. Now, it is important, or it's actually important to understand that we can do something about this. And so here we would like to make one parallel to the historical events that occurred previously. So moving on to the next one, once I will manage to find my cursor. Yes, so this is the sea level rise. It has been described so many times. But what is quite interesting is to have a closer look on a smaller sort of time capsules, if you would. And if you have a look in the Cold World War, World War I, World War II, what happened is that we have recorded the decline in the sea level. Now, how is that possible? One of the plausible explanations would be that the world events do create rainwater retention measures, not in a very optimal way, that's for sure, but definitely they are very effective. So, and actually what happens, well, what happens is in the Cold War area, we have tested many atomic bombs and many of the weapons of mass destruction. So overall, if you would make this an average, you would realize that there is almost no sea level rise during the Cold War area. And this is probably, I mean, here we are speculating, but one of the plausible explanations would be that the tests of the nuclear weapons have created sort of a shade in the atmosphere, which was protecting the atmosphere from overheating and lowering the amount of energy intake that we take. Good. Moving on to the next point. The different types of territories and the territory management, the impact that it has on the climate and on the emptying of the small water cycle. So these figures that you can see over here are actually based on Michael's calculations. And what we can see, this has been measured and calculated for Slovakia. It is the forests, not well managed forests, that they are responsible for the loss of water overall by 17%. The agricultural land, about half, and around 30% comes to the urban areas. But what is very important actually is to realize that we can do a calculation in terms of the surface area these land types take. And what comes out of it is that the urban areas, they are 5 times more efficient in terms of the water loss as the agricultural land, and they are approximately 10 times more effective in water loss as even badly managed forest. So that's probably the takeaway from this slide. Moving on to the next one, carbon. So, well, there's more forms of carbon in the nature, and honestly, there's also a couple of different perspectives that we can take on carbon. So, first of all, mention the carbon cycle. Here again, we do have a model where on the right-hand side there is the, let me just highlight over here. There is a place or a land with a significant runoff, and on the left-hand side you can see well-saturated land. And the impact it has is that in the healthy water-saturated land, the carbon sequestration can take place significantly. This is due to the fact that the photosynthesis can take place, and the water is actually the means or the vehicle on how to get the carbon sequestrated from the air down to the biosphere. So you, me, the trees on the pictures, this is all carbon-based life, but there needs to be some means on how to retrieve the carbon dioxide from the air and have it actually embedded within the molecules of our bodies. Now, this does not happen at all, or much less efficiently, if there is less water, which is the situation on the right-hand side. But the problem is that the amount of carbon is either identical or is rising. So the carbon dioxide needs to go somewhere, and where does it go? There's no place to go, no means to go, so it just remains within the atmosphere. Now, to support this statement, let me move on to the next slide, which would be the measurement in terms of the carbon dioxide molecule, ppm. These are long-term measurements. So what we can see actually the trend going upward. And one might say that, okay, this is the trend that we have set as humanity due to the consumption of the fossil fuels. But actually there is a different representation to this graph as well. And so before we go down the road, let me show you the small variation from 1 year. So what happens is that we have this trend going upward, but in the northern hemisphere, there is a majority of the continent located. So as soon as the spring and summer will kick in the northern hemisphere, this is where the photosynthesis starts and the carbon sequestration takes place. So on the left-hand side, you see this trend going upward, and when you have a closer look, you see that as soon as the photosynthesis starts, so around March, April, the trend will actually start not going that steep, and actually it will turn going downwards as the carbon sequestration will become very effective during the time. And again, as soon as the summer and the fall is over on the northern hemisphere, the trend is again setting going upwards. So bottom line, to interpret this graph, this might be an interpretation of humanity and the consumption of the fossil fuels, but also this might be a measurement of the ongoing progress in desertification. We are losing land, we are losing forests every minute that we speak and we are on this webinar, and there is less and less surface area that could sequestrate the carbon. So what we have actually, since there is less and less place for the carbon dioxide to get sequestrated, the trend is setting upward. Good, moving on to the next slide. Now we are going to have a closer look on a couple of the projects that us or our partners have built and the lessons learned from these projects. So what we are looking at would be a project in the UK. This project was done with the Flow Partnership and their local partners. And the intention for the project was actually to stop the series of floods that took place in the northern UK. So what we have is actually a couple of pictures of the water retention measures that were implemented. But what is interesting is in terms of the lessons learned is that there was a pressing need, apparently the danger of the floods, which could have been satisfied with leveraging the rainwater retention measures. And also the impacted territory was optimized in terms of the new water paradigm as a secondary in effect. Moving on to the next one, this is a project Blue Alternative based in Slovakia. These are the pictures from the 1999 down to 2009. So you can see how the ecosystems are thriving when there is sufficient amount of water. But what is actually very important is that this Blue Alternative was an alternative to an existing big dam project. Michael and his organization decided to challenge the big dam, and instead they proposed an alternate project on how to generate new water sources, which was much cheaper. By the way, worked out perfectly. And in terms of the lessons learned, what we have learned the hard way is that the rainwater measurements, the rainwater implementations, they're actually indirect or against the direct interests of the very strong lobbying groups. Namely, we are talking about the concrete, energy, big dam, and water and rainwater management. And this conflict, so that it can be effectively solved, there needs to be enough knowledge in general public to create a pressure against these lobbyists to make sure that the situation will be balanced out. And not everywhere there will be just a big dam, because as we can see in the Cape Town, it's not the big dams that solve the situation. The next of the projects would be the Slovak savings bank, a rainwater forest. Now, what happened is in 2005, there was a heavy disaster. There was an extremely strong wind, which ruined our precious national park. For you to understand, High Tatras in Slovakia, this is really like a very unique mountain chain that is heavily visited by the tourists, and it got cut down completely. So there were barely any trees left due to the fact that there was monoculture. So what you can see on the actual picture is the implementation of the rainwater measures that were sponsored by the Slovak Saving Bank. So Michael and his organization, they managed to revitalize parts of the forests, and no wonder these revitalized parts are actually doing great, even compared to the parts which where the rainwater measures are not implemented. We believe, and I mean, it's obvious that there is much more biomass and the trees are just thriving. So coming to the lessons learned, what is to take away from this project would be that the corporate social responsibility programs are out there and they may be used. But in order to get access to them, the topic they will be allocated to or the location needs to be attractive in terms of the public relations. Again, as it was in this particular case, it was the revitalization, which was sort of a primary intent, and secondary effect was the restoration in terms of the new water paradigm of the smaller areas. Moving on to the next one, the urban zone in Kosice. So this is an urban project. Again, this picture actually illustrates on how quickly the ecosystem, even in the urban zone, is able to get revitalized. So these are the pictures. Literally, within 1 year, there was a beautiful place where once upon a time there was barely something to look at. But what is important is that it was the identification of the correct benefit that was absolutely essential for this project to take place. In this place, it was the local environment improvement. So less dust, more places to walk, people would enjoy the location, and so on and so on. And again, the revitalization and the design and compliance to the new water paradigm comes in as a secondary. Also, what is important is that it's absolutely essential to have support of the local municipality. And it just happens that the funding or the investor for a particular project, they are not easy to be found. Good. Now moving on to the next one. Now we'll be talking about rainfall climate, and particularly about the aspect of the measurable results, the disruptive model behind the rainfall climate, and how we want to make sure that this is not going to be one shot, but it would be a long-term sustainable. So first of all, in terms of the messaging, we are actually stepping away from the climate change, and we call it extreme weather. It's easy to, the climate change is not necessarily tangible, and it's easy to be denied, whereas I would double dare someone to challenge the fact that there was a tornado in my garden yesterday, actually last summer, which really is the fact. So that is one change. Second, the standard communication as it is nowadays is that it's the carbon dioxide that we need to do something about, but we barely have no means on how to do anything about it. We are not opposing this opinion, but rather we provide an alternative solution where we claim that it is the water that is absolutely the key and takes the much more credit in terms of the externalization of the weather. And there's plenty a single person, regardless of where they are, how much money they have, what their location is, what their belief is, there's plenty of actions they can do. So this is in terms of the communication. Moving on to the next one. Now, before you want to implement something, first of all, you need to understand it well. And here we are coming to the combination of the measurement and also understanding of what we do. This picture, or some of you might recognize it, this is a picture of Mount Everest. And it is not here by an accident, but before we go to the explanation, I just must ask a rhetorical question. How would a single person move a mountain? There's no means on how to do that. But what we can do is, if all of us would decide to do that, the mountain can be moved easily. And the Mount Everest actually represents the 700 cubic kilometers or 170 cubic miles of water that we are losing annually and that we need to return back on the continent. And it just happens to be the 35 times of the volume of the Mount Everest from the sea level all the way to the top. Now, if all of us, we decided to do that, it would take every single human being 7 days a week, and they would create 100 cubic meters or 3,500 cubic feet of water retention measures. And probably within a year or two, for example, we would have under control a sea rise, which we cause by the loss of water from the continent. Now, is it easy to be done? Not necessarily. Now, how do we get this done? Actually, what do we want to do? I mean, I call this project the longest pilot period ever that I've ever seen. There has been a large number of years that took place, many of the locations, forming of the theory, which lead us to this point. And at this point, we are entering the phase 2. So the campaign is already ongoing. We are preparing ourselves for the crowdfunding. We need to create enough of the buzzword to make sure that the word would be out. What needs to be done? And now the question is, how does it get done? And the answer is, the rainwater retention measures can be implemented as a paid-for service. And the service is to be provided to the customers or to the businesses. And once we get sufficient support from these type of projects, which are being paid for, and we work we pick up the partners and we initiate more projects. And once the word is out, we created a critical mass. And when the critical mass is out, the corporate social responsibility programs become available. And when these become available, the projects will grow even bigger. And when they grow bigger, we move on to the next stage, where we start working with the governments, we start working with the regions, with the states. And this is, my friends, where we achieve what we want to achieve. This is where the change really is coming in place. Moving on to the next one. Now I'll be talking a little bit about the technology and the mechanisms behind. So as we stated previously, if everybody would work, then it would take 7 days. Now, not everybody is in position to do that. There are many people who are old. There are many people who live in the cities, so they have actually no land. There are many people who have some money, but they have no time. There are many people who want to help, they want to be volunteers, but they have no place to go to and actually do the volunteer work. There are some people who have plenty of capital, they would like to put it against something of the greater good, but they are actively seeking out the big projects. There is corporate social responsibility programs which are available, but again, this needs to be addressed well. So what do we do? It is the crowdsourcing that actually unlocks the projects that otherwise would be unreachable in terms of the actually making them happen, and also in terms of the scale. So the global rehydration portal would be actually a platform that you can think of, that would be a website. The plan is actually to turn the rainforclimate.com into the global rehydration portal. And this is a place where people who have the land, they come in and they say, hey, I have the land and it's located in a place ABC. The people who have the resources available, stating, hey, I want to chip in, or I want to help out, I want to become a volunteer. They come in, they say, hey, here I am, let me know whenever the project is around. And last but not least, we get hold of the capital. And what we do create is sort of platform, you can think of it as a marketplace, where these three components combine with the knowledge that we have, and we just make the projects happen. On top of that, since we would track every single project, we know how much water we already kept on the continents, so we can actually do the tracking publicly against the goal of 700 kilometers annually. So this is what the global portal is about. Moving on to the next slide. In terms of the technological development. So what we have done, actually, we did run a beta test last fall. We have created a specific drone which is capable to monitor, technically speaking, any region globally. So the monitor has a set of specific sensors that can measure the place, and that can actually transfer the data to the center of excellence. Now, let me swap over here for a brief moment, and actually this methodology in terms of the technical development allows us to monitor projects, and actually also to monitor the performance of the area or of the land in terms of the climate change. And for that, we have been awarded the AI for Earth grant by Microsoft. So actually it is a grant from Microsoft that they are making their resources available for solving the complex environmental changes. And actually we would be speaking on their conference next week in Prague, talking about what we want to do. So this is the website of the conference that is going to be taking place, organized by Microsoft. And Rain for Climate with our monitoring system is going to be showcasing on what is the new technology nowadays capable of. Moving on to the next one, in terms of how to get the services implemented. So it's essential to think on 3 levels. First one would be global, second one would be regional, and the third one would be local. And it's actually this third one, the local, which unlocks the power of the crowd. So in terms of the global, there will be Rain for Climate as a center of excellence, communication, campaigning, knowledge, and so on and so on and so on. But what is really important is that on the regional level, we are actively seeking out our affiliates. The affiliates are actually the people who are driving the drones. They are the people who are in the organizations, of course, who are responsible for collecting the information and feeding the information appropriate way. And in terms of the local, we are talking about the volunteers, communities, we are talking about the property owners, we are talking about the companies like construction company, water management, revitalization. We are talking about the people who want to work on the educational part. We are talking about the people who want to do something themselves, for themselves. Pretty much anybody. Now, and how would the actual implementation work out? It is the property owner and the affiliate that make the handshake, and the handshake is being then transferred as a single point of contact from the affiliate to the Rain for Climate. So this means that we know and we understand what the property owner wants to achieve. Now, at this point, it may be, okay, there's a problem with a lack of water. There's a problem with the flash floods. There's a problem with groundwater, which is very low. There's a problem with erosion, wildfires, you name it. The problems related to the climate change and actually to the desertification process, they are through the whole spectrum. But what is very important is that it is the rainwater retention measures that they are able to resolve these problems. Now, what happens next is that the affiliate actually scouts out the environment, the territory, and then the data is being sent to the Center of Excellence on the Rain for Climate side. Once we have processed the data, we send the detailed assessment to the affiliate, who again makes the handshake with the property owner. At this point, the property owner, should it be municipality or a branch owner, you name it, should have in their hands quite detailed analysis of the property with the proposed way on how to move forward so that their primary need can be addressed properly. Now, should the customer decide to proceed, we are going to proceed to the next stage, which is the implementation project. The implementation project is actually based on the data previously collected by the drone and also collected by a survey via the affiliate. And the implementation project gets delivered to the property owner. Now, this step over here is actually crucial because the local affiliate needs to take place and actually needs to translate the project to the country and state specific, and make it country and state specific, which means that, for example, when you create a project in Europe, it's going to be, the requirements are going to be quite different to be in the States or in, let's say, in Pakistan. So it is very essential to have an affiliate in place to make sure that the project as such will be translated effectively. Next, when the project will be actually taking place and the implementation takes place, it is the affiliate who works with the crowd. So they work with the volunteers, with the communities, or with the local companies that do actually the implementation. At this point, the jobs are created in this phase, and it is the job of affiliate to make sure that the implementation is going in alignment with the project, making sure that the rainwater retention measures are implemented in the quality that is expected. And last but not least, the compliance once the implementation has taken place. So again, there is a handshake between the affiliate and the property owner. And what happens is that the affiliate flies the drone above the land once again. The data is collected and is being sent to the Center of Excellence. And by the means of this CI2 monitoring, or climate impact index monitoring, as we call it, we assess the territory. And when the rainwater retention measures have been implemented carefully and in the sufficient quality, then after first rain, we are actually able to objectively measure on how the territory performs. And this means that we are going to issue the CI2 certificate to the property owner. And two things happen. First, the value of the property as such is increased due to the certification and due to the fact that since the certification is valid for 5 years, it is more than likely that the rainwater retention measures are going to be active for the next coming 5 years, making sure that the primary need is addressed and the property is actually, the value is being increased. And at the same time, we are going to record this property to the global rehydration portal as a property which is sort of checked. So this one is done, and that one does not need to be taken care of for the next 5 years. And we know the performance of the territory. We know the amount of water that gets retained over there, due to the fact that it is us who had designed the project, and we are familiar with the local conditions. Good, now moving on to the next stage. So if this is a service to be paid for, what happens with the money? First of all, this service is not necessarily to be paid for in every occasion. I mean, there would be instances where this needs to be done for free, or there would be instances where the situation is very specific. But should this be normal service provided, then also the profit does get distributed on all 3 levels. So again, here we are supporting the local economy, where the local crowd, they take part of the credit and part of the profit for their work. It is the affiliate that makes some money from, again, for their work. And then part of the profit goes to the global level. Now, what happens on the global level are basically 2 things. First one, we also, of course, are going to take care of the operational cost of ours. But actually, and more importantly, we do still invest in the Center of Excellence. So we have the R&D in progress. We are working on research to make things even more efficient. And actually, what we want to do is we want to have a campaign, an advertisement campaign aligned with the marketing communication previously stated. And this is how we want to make things happen, and how we want to get the message out and become it mainstream. So we can think of a 3-minute Super Bowl time, where instead of looking at a commercial product, people will be actually hearing on what can be done to stop the climate change. This is what the ultimate goal is. Now moving on to the next one. How do we want to manage such complex program? So actually what happened is, again, we are still thinking about the global, regional, and local. The global action plan has been done, it's available on our website. And then the regional action plans are actually created based on the logic and the specifics of the region. For example, we do have already ready the US action plan. For Australia, it would make sense to create one because Australia is sort of unique ecosystem as such. We will be closely working with Portugal in upcoming weeks. So as a side to that, we are going to create the action plan for the whole Iberian Peninsula, since it would make sense, and so on and so on. So based on the region, we split it up into how things should be done strategically, and then we are going to the actual implementations. Implementations will be chosen and will be done according to the action plan, which was designed for the region. And also in parallel to that, what takes place is the educational activities. And also part of the knowledge would be released as an open source, so we can support this also for people who want to do it themselves. Good, moving on to the next one. The disruptive model and innovation. So is this really innovative and is this really disruptive? Well, first of all, it's data-driven and it is proven to work. Second, it is respecting the existing laws and not only physics behind, but also psychology and human behavior, economics and marketing. We are using top-notch technology, which was never seen before, and we are actually working with data that never was done before. And when you think of the global portal, this is how we literally create market out of nowhere. Is this insane? Well, I guess no question about it. But that is precisely why we call this disruptive innovation. Moving on to the last part of the presentation, the benefits that we are bringing as a global program with this water conservation program. So first of all, the climate moderation and the air conditioning via the small water cycle. By this time, we should have provided enough evidence, not only scientific, but also the actual examples, that this should be undeniable. On top of that, we are bringing the flood erosion, wildfires prevention, and actually we are enhancing the creation of water sources. So from 5,000 cubic meters of rainwater retention measures, what you get is one water source, which is going to give you a liter of water per second, which is pretty good. On top of that, since we are capturing the water in the continent where it originally was, we are stabilizing the sea level and working towards decreasing the sea level. If the water is where it needs to be, the carbon sequestration takes place. We are actually increasing the production of the biomass, and sort of a side effect, there will be also boosted food production. The biodiversity kicks in as soon as the ecosystems will have enough chance to work well. We are supporting local economies through creation of the jobs, and actually there's a secondary effect which comes after the location has been revitalized. And this, as a solution, is by far cheaper and more effective than any other existing solution. So where are we now? So basically the global campaign is ongoing. Since you are sitting here with us, hopefully it reached you already. Please share the word, it's going to help. We are actually working, Michael, Jan, with a couple of colleagues of ours on a scientific article which would be published. And this scientific article is going to create, or is going to describe the actual thermoregulation mechanism of the Earth as described in the previous webinar. We jumped from 8 to 10 countries involved in terms of the experts. Now we've been lucky enough to be awarded the AI for Earth award by Microsoft and Esri. The R&D for the drone is ongoing, and we are preparing for the crowdfunding. And actually, as a result of the previous webinar, we initiated cooperation with people in several countries. So the communication is already ongoing. Once we get our hands free after this webinar and after the Microsoft talk, off we go, and we carry on with the discussion with them. Now, last but not least, so what can you do? Well, first of all, follow us on the social media. Please, if you can, sign up for a newsletter. Feel free to use the custom form. The contact form. The newsletter, we just did an upgrade to our website, so the newsletter can be found in the very top menu. You can contact us using the contact us menu, again here on the top, the social media right upper corner, or all the way on the bottom. Now, and there's one thing that you already can do, which is implement it. Feel free to donate. Actually, every dollar, every euro you spend over here is your investment to the future. So we are going to use this money for the mission of the Range for Climate. And that is also where I would like to ask for your support during the crowdfunding campaign. So as soon as we launch it, please, if we have your email addresses, we are going to bombard you a little bit with the emails. Please share, talk. The more people join, the more people chip in, the more likely we are going to achieve the massive project we signed up for. And I'd like to finish with my favorite quote from one of the greatest men ever walked the earth. So first they ignore you. Well, we've been ignored. Then they laugh at you. Well, we've been laughed at. And then they fight you. We fought. And then you win. So now it's our time. Thank you.